Hi everyone, in this video we're going to go over important alcohols and phenols. So the first alcohol is methanol, and this is also sometimes referred to as wood alcohol because in the past methanol was produced from the distillation of wood. So it literally came from wood. Nowadays it's actually created synthetically, and the way it's produced is by using carbon monoxide and then treating that with 2 molecules of hydrogen gas. And of course, there's going to be some catalysts to speed up the reaction, some heat and some pressure since we're using gases, and then we end up producing our methanol molecule. And this is a pretty simple molecule. It has 1 carbon, 4 hydrogens, and 1 oxygen. So methanol can be used as a solvent. It's a polar solvent, so it will dissolve other polar molecules. It can also be used as a starting material to create other chemicals. However, methanol is highly toxic if ingested. In fact, during Prohibition in the US, when alcohol was illegal, some companies or illegal bootleggers would use methanol instead of ethanol, which is what's typically in alcoholic beverages. But unfortunately, the methanol would cause blindness and or death. So a couple of years ago, actually, there were many tourists dying mysteriously in the Dominican Republic and Costa Rica. And scientists weren't really sure what was going on, but it was eventually discovered that the alcohol that was in their hotel room refrigerators, they were tainted with methanol, and they had just ingested too much of it. So that was very unfortunate. So, you always want to just be safe when you're using chemicals because they could be potentially toxic. Now, ethanol is what's actually in alcoholic beverages. And of course, again, if you ingest too much of this, it can have negative consequences. But this is also a pretty simple molecule, has 2 carbons, 6 hydrogens, and 1 oxygen. And ethanol can be distilled from different sources. I think previously I mentioned that if you mix molasses with yeast, you can go through the process of fermentation to produce ethanol. But it can also be produced commercially from ethylene. So that is this molecule here. Ethanol is also a useful solvent because it's also polar, similar to methanol. It can also be used as a starting material to synthesize other materials or chemicals, and it is present in fuel. So if you go fill up your gas tank, if you have a car, you might notice that the gasoline contains some ethanol in it. And of course, as I mentioned, it is found in alcoholic beverages and it can be moderately toxic depending on how much is ingested. The next alcohol is 2-propanol, which is more commonly referred to as isopropyl alcohol. And this is the main component of rubbing alcohol. So you might use this to disinfect your wounds or scrapes. So you might have this at home actually. I've also found that it's really useful for getting up anything like sap. So if you get something sticky on your shoes or even on, like my dogs will sometimes get it on their paw pads, I'll just kind of rub some rubbing alcohol on it and that should get it right up. So it's a pretty useful alcohol. The next one is glycerol. So this might sound pretty familiar. The IUPAC name is 1,2,3-propane triol. So you have 3 carbons and each one is connected to an alcohol. So this glycerol molecule is used as a food moistening agent, which sounds kind of weird, but it is non-toxic, so it's okay. And then it's also used for its soothing qualities, so you can use it to make soaps. And I'm not sure why cholesterol is shown down here. I apologize. That's a mistake on my part. Okay, so next we have 1,2-ethane diol, also called ethylene glycol, and this is more commonly known as antifreeze. So this is something that you might add to your gas tank in the winter if you live in really cold climates, and that's to prevent your engine from freezing. So basically what it does is it breaks up the molecules enough in your tank so that they don't freeze as easily. So it essentially lowers the freezing point. The next one is propylene glycol. This can also be used as antifreeze as well. So let's talk about some phenols. So first we'll just start with phenol. So remember, phenol is a benzene ring with a hydroxy group attached, or an OH group. And this is a weak acid, so it can lose its hydrogen to water, for instance. And then we end up forming the negative ion of phenol, or the conjugate base. So phenol can react with bases like potassium hydroxide or sodium hydroxide to form a salt. And remember, a salt has a positive ion and a negative ion that are creating an ionic bond. So in dilute solutions, phenol can be used as a disinfectant. Joseph Lister, an English surgeon, actually introduced the use of phenol as a hospital antiseptic in the late 1800s. And this really increased the rate of patient survival after surgery, because before that, they didn't have a very good method of keeping wounds clean during surgery, for example. However, phenol can be pretty irritating to the skin, so phenol derivatives have been used instead as disinfectants in more recent times. So for instance, O-phenylphenol, so we've got our phenol molecule here, and then there's a phenyl group or benzene ring coming off of that, and it's on a neighboring carbon. So that's why we use that O for ortho. Another one is 2-benzyl-4-chlorophenol. So we've got our parent compound, the phenol there, and then a chlorine is at position 4 across from our OH group. And then this group is called benzyl. So it's a benzene ring with an extra carbon attached. Phenol derivatives can also be used as antioxidants in food. So you've probably heard of antioxidants before. So these prevent oxidation within our cells. So for instance, our skin. One is BHA, and this is not too complex of a molecule. The name is very complex though. It's called butylated hydroxyanisole, and we just abbreviate it as BHA. The other one is called BHT, so that stands for butylated hydroxytoluene. So if we kind of break down these names, let's start with BHA. We have anisole, which is actually this part of the molecule. And Then we've got our hydroxy group attached up above, and then what's called a butyl group. And this is actually a tert-butyl group, but we just call it butylated. And then for BHT, we've got toluene down below. We've got our hydroxy group here, and then we have two butyl groups. Okay. So that's pretty much it for our lecture on, really useful phenols and alcohols. Next time we're going to dive into ethers, and that will start wrapping up the chapter. We're also going to talk about a type of functional group that's really similar to an alcohol called a thiol. So I will see you then.